Camera is currently out of focus. We can figure this out. There we go. Okay. This is Chapter 3, page 75, problem 84. We have a tennis server. This is my dude serving the tennis ball. He's going to hit the ball purely horizontally. When he does that, his goal is to strike the ball from a height of 2.5 meters above the ground, to sail sideways, clear a 0.9 meter high net, and then we're seeing where it lands. Does it land inside or outside of this 7 meter serving area? Okay, I've got it drawn right to the edge. That doesn't mean that's where it's going to go. We just want to see, does it land inside here or outside of there? Okay, so this problem has a couple steps. First thing is, it wants us to know, well, how fast does he need to hit this thing so that it clears the net? Second part, once we know it clears the net, is it going to land in? Third part, how long is it going to stay in the air? Okay, went ahead and wrote down the answers at the top of this just so that it's easy to check. His original velocity should be 26.13 meters per second, or thereabout. That lands in, not to steal the suspense, and the time takes 0.714 seconds. Okay, so let's run through this and see what happens. Alright, to solve this problem, you're probably able to talk your way through this by now. First thing we're going to do is make a variable list, horizontal and vertical motion variable list. Okay, so let's do that. So for the horizontal direction and the vertical direction, what I need to do for this problem is break it up into a couple of smaller chunks. First part I care about is I got to get the ball to go from here and clear the net. There's a certain minimum speed I must have to get it to travel 15 meters horizontally and only drop 1.6 meters vertically. So that's my first step, is figure out, well, how hard do I have to hit it just to get it over the net from where I'm surfing? Second part then is, alright, now it doesn't land in it. So this variable list is only for the first 15 meters right now, 15 horizontal meters. Okay, so horizontally, my original velocity, I don't know what it is. That's what I'm trying to find. My final velocity, I don't know what it is. I know these two are the same, because there's nothing pushing or pulling to make this speed up or slow down. My acceleration is 0. My time in the air, I don't know. I'm going from here to here. My distance traveled has to be at least 15 meters. Okay? I guess exactly 15 meters, because I'm looking for how fast do I have to get it to go so that it travels 15 meters in that time. Alright, vertically. So hitting this thing purely horizontally, my initial vertical is 0. My final vertical speed, I don't know. My acceleration, negative 9.8 meters per second squared downward. My time, I don't know, but I know horizontal and vertical times are the same. My original Y position is 2.5 meters above the ground. My final Y position, I need to be 0.9 meters above the ground. Okay, I chose to use original and final this time rather than just using delta Y. For no particular reason, I just felt like it. Okay, so with these two, acceleration with the original, looks like this would be a pretty straightforward. Let's figure out how much time it takes to go from here to here. Once I know that time, I know delta x, I know time, I can find my v average, which is the same as my v original and my v final, so I can figure out that speed. So the key here seems to be find the time vertically and use it horizontally. So vertically, I'll say y final equals y original plus v original vertical times time plus 1/2 a t squared. My original vertical velocity is 0. This becomes y final minus square y original times 2 divided by a, where a is negative g. It's equal to g squared. Let's go ahead and plug in some numbers. Y final, 0.9. Y original, 2.5. A, negative 9.8 meters per second squared. Square root that puppy. Going to be a time. Again, this is only the time it takes to go the first 15 meters. So I plug all that in. I get 2 times 0.9 minus 2.5 is negative 1.6. 1.3. Negative 1.6 divided by negative 9.8. Take the square root of that. I just hit the wrong thing. Square root of that. Add the wrong thing again. Take the square root of that. We get a time of 0.571 seconds. Again, that's only the time in the first 15 meters. Alright. Now to find that horizontal speed, do delta x equals v original times time. V original, v final, v average, all the same horizontally. Delta x over t is equal to v original. Delta x is 15 meters. T is 0.571 seconds. Looks like the speed I've got to walk that ball at 15 divided by 0.571. I get 26.25 meters per second. Earlier I listed the answers. I think it's because they didn't round their time. They got 26.13. I get 26.25. Close enough for us. Okay, part B. Does this thing land in? Okay, well you can keep, now that you know it's going to clear the net, you can keep all the same variables, except that on your vertical side, change the y original, keep it as 2.5, but change the y final to 0. Okay? And now you know the horizontal original speed. So figure out how much time it takes for the ball to go from here to the ground. Multiply that by that horizontal speed, see if it lands in or out. If it helps at all, rewrite that vertical list, or that variable list. I guess it doesn't really matter too much. So I'll do that just so that you know exactly what I'm doing. Okay. Horizontally and vertically, my speed's still going to be 0 meters per second. Now I'm going from strike to ground. Because this is the entire service distance. From the instant I hit it till it hits the ground. Vertically, my speed starts at 0. I don't know what it ends at. I know my acceleration is negative 9.8. I don't know how much time that takes. But I know my delta y is going to be negative 2.5 meters. It's going to fall that far. So horizontally, I know my speed now. I'm going to go with my 26.25 meters per second. My distance may come off, be off a little bit from theirs, but I'm not too worried. My final is the same thing. Acceleration 0, time, we don't know. We know the vertical and horizontal times are the same. And delta x, I don't know. But if I can figure out this time, I know how far it's going to go. I can calculate that. Okay, so on the vertical side, I'll say delta y equals the original t plus 1/2 at squared. The vertical motion. My original vertical speed 0. So this becomes pretty straightforward. 2 times delta y divided by the acceleration t squared. 2 times delta y, which is negative 2.5 meters, divided by the acceleration, negative 9.8 meters per second squared. Square root of it with a t. So it's going to spit out that t, total time in the air, 2 times 2.5 is 5, divided by 9.8. Take the square root, and then off the camera. I get now the time is 0.714 seconds. To me, it almost seems like they asked these questions out of order, because that is our answer for part C. Now we just got to find out whether it lands in or out. It's going to take that same amount of time to get to the ground, but now we just need to see, is it in or is it out? So delta x equals v original times the time, the horizontal motion. Okay. At delta x is equal to v original, which is 26.25 meters per second, because I rounded. And the time is 0.714 seconds. I multiply those two. 6.25 times 0.714 seconds. I get, that splits out 18.74 meters. 15 of those meters are getting to the net, so then I've got another 3.74 meters. That's definitely less than, moving this out on something you can't see. 15 of those meters are going to get me to the net. The remaining 3.74 of those meters will get me that here, someplace. It's definitely less than 7 meters. That ball lands in. Okay, and that's the end.